works to divide polynomials. Sometimes synthetic division can be used. When you can use it, you should use it because it's a lot quicker and easier, but you can only use it in certain cases. So what are the limitations? So if we're finding a quotient of two polynomials, the denominator has to be first degree, so it has to be linear. You can't have anything higher, or you can't have a higher power of x than just x to the first. And it needs to be in the form x minus some number. Now it could look like x plus a number, but if I had, like for example, it could look like this. The denominator could look like x minus 3. That's fine. Okay, that is x minus the number 3. What if I had a denominator that looked like that, x plus 2? Is that in the form x minus a number? It is. X minus negative 2. Yeah, that's the same thing as saying x minus negative 2 is all. We wouldn't write it that way, but it is the same thing, right? So technically you could really have a plus or a minus sign in that binomial in the denominator. Either way, it's going to work, right? But the coefficient of x needs to be 1. Okay, you can't have a number in front of the x. It has to be in the form x plus or minus some number. Okay. When it looks like that, then we can use synthetic division. Okay, so again, there's same thing, right? Denominator has to be of the form x plus or minus some number, c. So you tell me, can we use synthetic division in this one right here? Yeah, that's fine. We could, right? We can use synthetic division. Could I use synthetic division for that one?
No.
No, how come?
X squared.
X squared, yeah, we got a problem, right? We've got this x squared, so no. Yeah. I'd have to use long division for this one. I could not rely on synthetic division. How about that one?
Yes.
Yeah, I'm fine. How about that one?
No.
No dice. How about that one? No, can I use it there? The way it's currently written, I cannot. And how come? What's the problem? Yeah, that 2 is causing problems. So, okay, I could, but the answer is no, but. But there is a way we could do this. We could multiply the top and bottom by 1/2, and then I could do it. Does that make sense? Okay, so I could change that one. And that's kind of an inconvenient. When I have fractions in there, it's inconvenient, but it does technically work. Okay, a lot of times, books are going to say no on that one. And our textbook would say no. I mean, I think almost every high school book is going to say no, you can't. But we're better than that. We can. I'm going to show you guys some examples of how we could actually. I don't know if we'll get to it today or not. I think we probably will. We'll actually go through an example where we use synthetic division to do a problem like this. The argument is, what's better? Is it easier to have to go through the hassle of using synthetic division here, or do we just, do long division? In long division, as you saw a couple days ago, it's a little bit of a process, right? I mean, it's better to avoid it if you can. I don't know. Personally, I would use synthetic division, but I don't know that everybody agrees. I mean, I think when you get good at it, if you do it a few times and you start to get the hang of it, it's not so bad. I think it's easier personally to rewrite it and use synthetic division, but you can be the judge of that. Okay, on the test, you can do it either way. Okay, so let's practice this a little bit. How do we do this synthetic division stuff? I'm just going to show you the process. I'm not going to. I have in the past kind of gone through a little proof of this and kind of tried to illustrate why it works. I don't think I'm going to do that. I don't think you really accomplishes that much. And we're going to do some other stuff that'll kind of point out maybe why it works anyway. Some of the theorems that we attach to this. We're going to learn how to divide things synthetically, and then we'll extend that, and I'm going to introduce 2 very important theorems in algebra, the factor theorem and the remainder theorem. And those give you a little insight into why synthetic division works. But I'm just going to show you the process. So how does this work? If I'm going to divide 2 polynomials, I set up, and I think our book I'm used to doing it this way. I'm used to writing it as one big L-shaped bracket. I think our book does things a little differently. I think instead maybe it does it like that. I can't remember. Well, we'll look at some examples both ways. So we'll write it two different ways. Different textbooks represent it different ways, but the process is always the same. What do? Okay, you're going to make a row. First of all, to start things off, you're going to make a row that includes only the coefficients of the numerator. One nice thing about synthetic division is you never write down a variable. It's only numbers. That's why we call it a synthetic process. Synthetic processes only use coefficients or numbers. The variables never show up. So this is synthetic division. I need to write down my coefficients of the numerator. What are they?
1, 2, 2.
Okay, 1. I disagree with 2.
4.
No.
No.
What is it?
0.
0. How come?
They can't.
Because I have to write all the coefficients in the numerator, right? All the coefficients of every power of x, just like we did with long division. So I get the coefficient of x to the 4th is 1. What's the coefficient of x cubed? 0, because it doesn't show up, right? If I'm missing a term in my polynomial, I have to include a 0 coefficient, right? Just like in long division, we have to have a column for every power of x. And it's not just a good idea with synthetic division. I mean, technically, you probably could make long division work without doing that, although you'd make tons of mistakes. You can't in synthetic division. It's a requirement of the process that you have to have all the coefficients, including 0 coefficients. So we have to start off with the polynomial in standard form and then write coefficients. So I get 1, 0. What's my next coefficient? 2. Next coefficient? -2. Last coefficient? -1. I always end with my constant, right? Okay, now something else that I don't think our book does, and this is something I really think you need to do, is you're going to put a box underneath the constant, below the bracket, underneath the constant. Notice I left a gap here. You're going to leave a gap for another row inside this L-shaped bracket. The other row is just really there to help you, just for computational purposes. It's just there to help you calculate the numbers that show up in the bottom. But really, there are only a couple important places. Top row is important because it represents the numerator. The bottom, below the bracket, the numbers that show up are important because they're going to give us the answer. And the number that goes out front is important. Now, the number that goes out front has to do with the denominator. Okay, the number that goes out front is the 0 of the denominator. So there's my denominator. What's the 0 of that denominator? 2. Everybody get that? The value that would make the denominator 0 is 2. And because synthetic division always has to be in the form x plus or minus some number, what's the relationship always going to be between this number right there and that number right there? Not reciprocal. What's the word you're looking for? Opposites. Yeah, they're always going to be opposites, aren't they? Every time. Okay, so I get a 2 out front. All right, so now I've set up the process. Give me thumbs on that. Everybody okay with how we set that thing up? Okay, not so bad. 0 of the denominator goes in front of the bracket. The coefficients of the numerator go inside the bracket. Okay, now we do the process. Well, what's the process? So the process is to start the process, you're going to drop the first coefficient down below the bracket, and then you start the machine. Once you drop a coefficient below the bracket, then the machine automatically kicks in and it multiplies by the number out front. So we get 1 times 2 is 2. And then we add vertically. You do the opposite of long division. Long division, you always subtract vertically, right? Synthetic division, you add vertically. So 0 plus 2 is 2. Okay, well, I got a new number below the bracket, so what do I automatically do? multiply by the 0 that's out front. 2 times 2 is 4, plus 2 is 6. Okay, which starts another cycle. Already got another number below. 6 times 2 is,
12.
whoops, I don't need a plus there. Oh, darn it. I'll do that. We'll do that. 12. Add those up, what do I get?
10.
10. What's next? Okay, so what do I get here? 20. And I add those up, and what do I get? 19. Okay. So what's the meaning of all that? That's my answer. Now, how do we interpret that? Okay, well, this is the remainder box. So that's my remainder is 19, okay? These are going to be the coefficients of my answer. Now, the best way, so what does that mean? Well, this is going to be the constant, right? The coefficient that's next to the remainder box is always going to be the constant. The one to the left of that is going to be what? Coefficient of what? X. Next one's going to be coefficient of x squared, then, and if I kept going, it'd be x to the fourth and x to the fifth and so on, right? Okay, so it's always easiest to start, does it make sense that it's easiest to start on the right because you know what that one is, that's the constant? If I have a great big string of numbers, it's difficult to start on the left because I'd have to kind of count and figure out what power of x that is. So just go backwards. Always start with the constant and then just increase the power of x by 1 with each term, right? So what's my answer then? Okay, so my answer is, yeah, so we know that's going to be an x, right? That's going to be an x squared, and that's going to be an x cubed. So my answer looks like x cubed plus 2x squared plus 6x plus 10 plus what?
19 over x minus 7.
There you go. My remainder is 19. And what does the remainder do? The remainder is what remains over the denominator. Exactly. And so my original denominator was x minus 2. So that goes in the bottom. That's my answer. Make sense? Okay. Quick, right? Way quicker than long division. I mean, once you get the hang of this, you can do a synthetic division problem in like 10 seconds. It's really quick. Long division, not so much. It takes a little more effort, right? Okay, why don't you guys try one of those? Jump to the board and try one and talk about it. Okay, so let's make our synthetic bracket. Now, I'm going to make this one. I think the book makes this, the synthetic bracket, a little differently, so I'll just write this one differently. It means the same thing. I'm going to go like that. Okay, and then the 0 of the denominator goes there instead. Okay, same thing though. It means exactly the same thing. What do I write in my first row? 6, 0, negative 9. Now that's my constant, so I can put my remainder box underneath. Okay. What number goes out here? 3. Okay, good. And then what's the process? Drop the 6 down. 18. Add, which gives me multiply, right, which gives me
54.
And what do I get for my remainder? Okay, so then what is my answer?
6x plus 18 plus 45 over x minus 30.
Okay, good. There's my answer, right? Good. No big deal. All right. Okay, so what about one like this? What about one where I've got a denominator that's linear, but the leading coefficient is not 1? Okay, so what would I have to do to this fraction? Multiply top and bottom by 1/2. Yeah, okay, good. So first step, let's do that. Let's multiply top and bottom by 1/2. So if I distribute a 1/2 all the way through, that's going to give me 1x to the 4th plus 13/2 x cubed plus 7/2 x squared minus 12x minus 7. Everybody agree?
Yeah.
And then on the bottom, I just get x plus 3/2. Okay? So now let's set up the synthetic division. Okay, everybody agree with the line of coefficients?
Yeah.
Okay, what goes out front?
Negative 3/2.
Negative 3/2, good. Okay, and we'll start. So what do I do first? Okay, so I could, maybe. Okay, so we drop down the 1, right? I get a 1. And then I wouldn't put that variable there, right? But just to remind you what that's going to be in the end, right? That's going to end up being an x cubed. Forget about the variables for now. Okay, and then what's next? Multiply. 1 times negative 3/2 is negative 3/2 plus 13/2 is 10/2, which is 5. Okay, good. So that's convenient. Okay, now what? Multiply, which gives me negative 15/2. Maybe I'll just get rid of these things.
4 negative.
Okay, does that make sense? So then we get negative 15/2. If I add those up, I get negative 8/2, which is negative 4, right? Negative 4 times negative 3/2 is positive 6, isn't it? Right? Positive 12/2. Negative 12 plus 6 is negative 6. Negative 6 times negative 3/2 is positive 9. And look, I end up getting then a remainder of 2. Okay? So those are the, and now we could add maybe the coefficient, or add the variables in there. Just I always put them at the bottom just to remind myself which one goes with which. So constant, x, x squared, x cubed. Right? So that gives us that, right? Everybody agree? I get this is the polynomial part of my answer, and I get a remainder of 2. But look what the remainder is over. It's over this crazy denominator that has a fraction in it, right? We probably don't want to leave it that way. We probably want to return the denominator to one that only involves integers and not fractions. Okay, so how would I do that? Multiply by 2. But I can't just multiply only the bottom by 2. What do I have to do? And multiply the top by 2 also, right? So if I multiply both the bottom and the top by 2, then that's going to clear the fractions, and I end up with my final answer, which just looks like that. Okay, make sense? All right, you guys try one of those. Okay, help me out here. What do we need to do first in order to be able to use synthetic division? What do I have to do first here?
Multiply by 1/2.
Distribute in 1/2, right? So I'm going to have to then, if I do that, if I distribute 1/2 through the whole thing, top and bottom, I'm going to get, what, x cubed minus 11/2 x squared minus 25x minus 27/2 divided by x plus 5/2. So if I plug that into a synthetic bracket, what do I write for my top row? 1, no variables, right? 1, negative 11/2.
Negative 25.
Okay, what do I have to put down here? Remainder box. Yep, and that's very useful because then you always know right away. It's easier to keep track of what's what when you get your answer. What goes out front?
Negative 5 halves.
Okay, and then we just do our synthetic division. So what do I do first?
Drop down the 1.
Drop down the 1. No variables, right? I did that. I kind of said a bad example last time. No variables. What do I do now?
Multiply 1 by -5.
Okay, if I add those, what do I get?
-16 halves, so it's -8.
-8, good. -16 halves, good. What goes here?
20.
Positive
Positive 20, yep, good. Add those up, I get -5, which gives me
-25 halves. Oh, positive.
positive 25 halves. Which means my remainder is what?
-1.
-1, okay. Good, so then my answer is, that's my constant coefficient of x squared, right? So I get x squared minus 8x minus 5 plus what over what?
Wouldn't it be -1?
It would. I'll just put a -1 at the top. You're right, yeah. Okay, and what goes in the bottom?
2x. X plus 5 halves.
X plus 5 halves, yeah. So last step, declare fractions in my fraction. 2 over 2, yeah. And, obviously I multiplied by 1/2 to put this into the proper form to do synthetic division. I'm really just reversing what I did initially by multiplying top and bottom by 2. Reciprocal of that, right? Okay? Yeah, okay, enough said. And so then my final answer doesn't change the polynomial part, but my fraction now looks like, tell you what I'll do, let's put the negative out front. Plus -2 on the top is the same as minus 2 over 2x plus 5. Okay, putting the negative out front is okay to do, isn't it? In this case, it's always going to be okay to do, because when you're doing synthetic division, you're only ever going to end up with one term in the numerator, which is going to be a number, right? That's a little bit, you got to be a little careful with that when you're doing long division, though. If I pull a negative out of the numerator, remember, it has to be distributed to everything that's in the numerator of that fraction. So you got to be careful with negatives when you're using long division. With synthetic division, you can always put the negative in front of the fraction every time. You're never going to have an issue.